Hello, hi. There's an update from ISRO that India's Chandrayaan-2 observes effects of the coronal mass ejections from the sun on the moon. First ever observations showed an increase in the total pressure of the dayside environment of the moon. That is, getting into the details, Chandrayaan-2 observes effects of the coronal mass ejections from the sun on the lunar exosphere. The picture that you are seeing is an artistic rendition of the coronal mass ejection hurled by the sun towards the moon and its effect on the dayside lunar exosphere. And for visuals only, not up to the scale. About the picture and getting into the details, India's Chandrayaan-2 lunar orbiter has made the first ever observation of the effects of the sun's coronal mass ejection CME on the moon with one of its scientific instruments, Chandra's atmospheric composition explorer 2 on board, that is CHACE-2. Observations from CHACE-2, that is Chandra's atmospheric composition explorer 2, showed an increase in the total pressure of the dayside lunar exosphere, that is very thin atmosphere, when the coronal mass ejection impacted the moon. The total number of neutral atoms or molecules present in an environment per unit volume. So the total number density derived from these observations showed an increase by more than an order of magnitude. This increase is consistent with earlier theoretical models which predicted such an effect, but Chandra's atmospheric composition explorer 2 CHACE-2 on board Chandrayaan-2 has observed such an effect for the first time. The Earth's moon has a very thin atmosphere which falls under the category of exosphere, implying that the gas atoms and molecules in the lunar environment rarely interact despite their coexistence. The boundary of exosphere is the surface of the moon, and hence the moon's exosphere falls under the category of the surface boundary exosphere. The exosphere on the moon is produced by a number of processes which involves the interaction of the solar radiation, solar wind, that is ions of hydrogen, helium and small quantity of heavier ions emanated from the sun, and the impact of the meteorites with the surface of the moon. These processes liberate atoms, molecules from the surface of the moon, which become a part of the exosphere. In general, the exosphere of the moon is highly sensitive to even small variations of the factors that are responsible for its creation. And such a factor is emission of the coronal mass of the sun, known as CME, short form of coronal mass ejection. The coronal mass ejections, or CMEs, are the events when the sun ejects significant quantities of its building material, comprising mostly helium and hydrogen ions. These effects are significant on the moon, as moon is an airless body, that too deprived of any global magnetic field, the presence of which would have shielded even partially the solar effects on its surface. This opportunity to directly observe the effects of the coronal mass ejection impacting on the moon came in an rarely occurrence on May 10, 2024, when a series of coronal mass ejections, CMEs, were hurled by the sun. This increased quantity of the solar coronal mass that impacted on the moon enhanced the process of knocking off the atoms of the lunar surface, thereby liberating them to the lunar exosphere, which manifested as the enhancement of the total pressure in the sunlit lunar exosphere. This observation would provide scientific insights in the understanding of the lunar exosphere and space weather effects on the moon. Apart from pushing the edge of our scientific understanding about the moon and the lunar space weather effects of the sun's emission on the moon, this observation also indicates the challenges of the building scientific basis on the moon. Lunar base architects need to account for such extreme events which would temporarily alter the lunar environment before the effects subside. And the difference is taken from the paper Impact of the Coronal Mass Ejection on the Lunar Exosphere as observed by CHACE-2, that is Chandra's atmospheric composition explorer 2 on the Chandrayaan-2 orbiter, from the Geophysical Research Letters, Volume 52. Okay, you can have a look at the picture now. Have a nice day. Be curious. Thank you.